Hello everyone, and welcome back to another video. Today we will discuss one of the most irrefutable examples of biogeography and the theory of evolution. Island biogeography, or insular biogeography, is a field within biogeography that examines the factors that affect the species' biodiversity in an isolated environment. The theory of island biogeography states that smaller islands have fewer plants and animal species and less immigration, while larger islands have the opposite effect, a larger amount of plants and animal species, but have more immigration from outside species. This is because smaller islands are simply harder to immigrate to, and this creates less diversity on the island. On a larger island, it is easier to migrate to, as it is generally easier to find a larger island than a smaller one. This lack of isolation creates more biodiversity on the larger island. This theory is not the only thing that is discussed when explaining island biogeography. Today we will look at two ideas that are part of island biogeography: island dwarfism and island gigantism. Island dwarfism, or insular dwarfism, is a rare process in biogeography and happens when a large species' size decreases throughout generations. This is simply explained by natural selection, the process of genes being picked by which animals can reproduce. However, this begs the question: what is causing these species to decrease in size when it is in an isolated environment? We will first explore two different examples of island dwarfism to answer this question. First, we will discuss a well-documented example, the Cretan dwarf mammoth. The Cretan dwarf mammoth is the smallest mammoth to have ever existed. Only 1 meter in height and weighing around 110 kilograms, this extinct mammoth is one of the many different mammals that lived around the Mediterranean that were affected by island dwarfism. However, the question remains, what evolutionary pressures were on the species that caused them to become smaller? It all has to do with their environment. The isolation of this environment meant that there were less food overall on the island, and that those that could not shrink went extinct. Another reason is the lack of predators on these islands. Those animals that traveled to the island and used their size to ward off predators found a land without this pressure on their size, so they were able to evolve smaller to require less food to live. Island dwarfism is just one process of island biogeography. There is also the opposite: island gigantism. Island gigantism, or insular gigantism, is a more common process than island dwarfism because this affects smaller animals, and there are a lot more smaller animals than larger ones. Island gigantism is essentially the opposite of island dwarfism, where instead of species evolving smaller, they evolve larger over the generations. This can cause insane proportions that are unthinkable to the megafauna of today. Last week, I mentioned a species called the elephant bird that lived in Madagascar before going extinct in the 1700s. This bird is an example of island gigantism, as the ancestor of elephant birds and the kiwis are Parapteryx. Parapteryx were small birds that weighed about 200 to 400 grams, while the elephant bird is estimated to have weighed about 730 kilograms. Parapteryx is theorized to have originated in the Australian subcontinent and flew to Madagascar after the breaking up of Gondwana. This isolation caused them to grow to massive proportions. A more famous example of island gigantism is the dodo. The dodo is a type of pigeon that found itself on a paradise-like island, Mauritius. When they first arrived, there were no predators and plenty of food. Because of this, dodos evolved to become flightless, plump birds that were perfectly adapted to this environment. The more famous example of island gigantism is my favorite and one of the most extreme. Millions of years ago, one of the largest pterosaurs to have ever existed was Quetzalcoatlus, and somehow this large reptile managed to find itself on an island where there is plenty of food and managed to evolve even larger. This new species was named Hatzegopteryx. Hatzegopteryx was a humongous creature with a wingspan of 10 to 12 meters and a neck that was 1.5 meters long. This creature was most definitely the apex predator of its niche, as the generalist of the island called Hateg, which is an island known for its dwarf dinosaurs. Now for the big question: what caused these creatures to grow so large? Wasn't it the isolated environment that caused other species to shrink? Well, it is again all about the environment. An environment that is so full of food and with no predators can cause small animals to grow, because those species that increase in size are less affected by food scarcity as larger animals and can go a long time without food. Island biogeography can explain so many things about evolution we didn't know could happen. However, due to humans moving all over the world, invasive species and overhunting has caused a large majority of the extinctions of native island populations. The elephant bird and the dodo are both known to have gone extinct due to human-caused events. In all honesty, it is too late for the majority of the species. However, island fauna like the kiwi still have a chance to be saved from this extinction. I hope everybody enjoyed today's discussion and will stay tuned for the next video next week.